Hi, this is Felix, and today I'm going to have a little video on the subject of consciousness. First of all, let's see if I can spell it. N-E-S-S. I believe that's correct. In particular, we're going to talk about the Penrose Hameroff theory of consciousness, called ORCH-OR for short, and even shorter, OOR, is sometimes referred to as. This stands for Orchestrated, S-T-R-A-T-E-D, Objective Reduction. Sometimes reduction is referred to more commonly as a collapse of the wave function, but that is what we're talking about in relation to reduction. So with this theory, we will see that consciousness is quantum in nature. Consciousness is not something that is merely emergent out of the connections in our brain. It is also not an illusion. So let's start out drawing a little schematic of a neuron. Let's see if I can do this. There's the soma. We have the axons. The dendrites are very prominent at the top. You know, for some reason, this schematic, this cartoon of a neuron, looks a lot like a saguaro cactus. I wonder why that is. But also, it looks like the Greek character psi, which has meaning in the science of consciousness. Anyway, within the neuron here, I want to point out the dendrites, because it has been long believed that consciousness occurs because of the connection amongst neurons. That consciousness is an emergent property because of all these connections and the firing of neurons. However, we're going to concentrate on the area which was always thought of as the input. In reality, we find there's a lot going on inside the dendrites. This is the top part of the neuron here. There's so much going on at the quantum level that there's a massive increase amongst many orders of magnitude in computing power because of this. So let's take a look here. Inside of the dendrites, we will find there are structures called microtubules. These microtubules connect to one another, communicate with one another through microtubule associated proteins, and also they can connect dendrite to dendrite through areas called gap junctions, where these dendrites connect to other neurons. So let's have a look at one of these microtubules, making a little bigger picture of a microtubule. You have a cylindrical object, and it is made up of proteins called, of all things, tubulin. It is a peanut-shaped protein, and they form in lattices. They self-assemble along the entire length of the microtubules, rather, within the brain. Now again, going to a deeper level, we will find that within these tubulin proteins are something that is ubiquitous in biology, in life, and that is the benzene ring, forming what are called aromatic molecules. Again, these are very common in life. They are just about everywhere. But they have some interesting features that allow us to see quantum effects within the brain. Now, it's very important to our discussion that these aromatic molecules, these benzene rings, form what are called hydrophobic pockets within the protein. Now, that is very important. Let me see if I can write the word hydrophobic. Of course, that means water repellent. And that's important because this allows these benzene molecules to be isolated from the environment. And if it wasn't for this, quantum events could not occur. So within the brain, you think your brain is warm, wet, and noisy. Well, it does have areas that are very small, microscopic areas that are isolated from the environment. Now, Dr. Hameroff had studied microtubules for several decades, and he understood that microtubules accounted for a vast increase in computing power within the brain. But exactly how did that lead to consciousness? This was just kicking the can down the road, so to speak, saying that, okay, well, this amount of computational power won't do it. We need a lot more. Well, this is where Dr. Penrose came in. Dr. Penrose believed that in the quantum world, there were effects similar to consciousness, especially effects that were, and this is an important concept, non-computational. See if I can spell that. Non-computational. This is important because we all understand, or we've heard of, the collapse of the wave function. We understand that the quantum world deals with probabilities. This isn't the same as a normal computer. Certainly there have been some theoretical talk about creating a quantum computer. But what's important here is in the benzene rings. This is where Dr. Penrose and Hameroff realized together that there were superpositions between one state in a benzene ring and another. And again, this is for demonstration purposes. You need more than one benzene ring together to be able to do this. So we see that these benzene molecules are isolated from their environment, and we've heard about the collapse of the wave function occurring because of some other stimulus, some outside source of consciousness even looking at the system alone might cause collapse of the wave function. However, when isolated from the environment, a superposition will collapse on its own, depending upon the mass of the system. Now, this is important here. That becomes what is called objective reduction. It is not something that happens randomly, but occurs given the known laws of physics. So objective reduction, let me write reduction here, this is important, occurs within these benzene rings, and this also creates a superposition of these various tubulin proteins. So when isolated from the environment, something quite fascinating happens. These tubulin proteins, being in superposition and being arranged in lattices along the microtubules, pick up patterns. Where are these patterns coming from? They're coming from the quantum world. Now, at this level of the universe, we are definitely talking about theories that are difficult to test, no doubt. But Dr. Penrose believes that the most basic element in the universe could be a type of angular momentum known as spin. These various spins, in turn, form networks in relationship to one another. And they do follow various rules of their own. These networks, however, encode all of the information in the universe, and they don't so much obey the laws of the universe, but create the laws of the universe. So within these spin networks is encoded all the information in the universe. It is these spin networks, in turn, which are imparting the patterns onto the microtubules. So the structures within the brain merely evolved to take advantage of what it was the universe was providing, and indeed the very structure of the brain was influenced by the information in the universe. Every time we have objective reduction or a collapse of the wave function within the brain, this creates a conscious moment or a proto-conscious moment. Taken together and organized or orchestrated by the structures of the brain, this creates consciousness. Now, quantum effects are being found in nature in various places. This includes structured water and even in photosynthesis. So if leaves can take advantage of quantum effects within the universe, why not our brains? Why not our minds? Again, this is Felix. Until next time, thank you for watching.